In this video, I'm going to be going through Chapter 2 of the Year 11 or preliminary course of Engineering Studies. And the focus today is going to be electricity. So to start off with, I have a couple of posts when I talk about electricity. So if you're using my photo referencing scheme, I have Michael Scott talking about Scranton Watt, the Electric City. And I also have the computer from Electric Dreams, which is a movie I saw when I was a kid and very influential for me. I have a picture about transistors and everything to do with logic gates, which is Derek from Veritasium, or if you're a Hello Internet fan, Dirk. And I have electrical danger, so danger high voltage. It didn't occur to me to put on Electric 6, but I might put that on when we get to that stage. Okay, so let's start off with, they call it that because the electricity. Anyway, I ruined that, and I'm just going to keep on moving. Okay, so what we probably do is probably the best place to start is to have a quick look at the textbook and see what the textbook says. Well, first of all, we're going to do some junior physics. So stuff that you probably should have learned in physics, you should have in science, in probably somewhere between year 7 and year 9 physics, you should have learned about current, potential difference, which I'm going to call voltage, resistance, and conductivity. We're going to learn about drawing a basic circuit. We're going to learn about some parts of a circuit. We're going to learn in Chapter 2, specifically, we're going to learn about electrical safety. We're going to learn about the difference between AC and DC. We're going to learn about, Lenz's law and reactance and impedance. We're going to learn about magnetic induction and how that we use motors. And we're going to learn about electrical motors, both DC and AC motors. When we talk about DC motors, we're going to learn about back EMF, and then we finish this unit, we're on to drawings. Okay, so it's worth pointing out that I will look at some of what we're going to do later in the year as well. So when we get to Chapter 4, we're going to go over electricity again. And I like to try and talk about some of this stuff a little bit earlier because I like to give people a context for what we're going to learn. I'm not going to go into quite as much detail because that might be too much. But let me get electricity. Okay, so I think it's pretty important that we understand Ohm's law. I don't think you can really learn about electricity without having done Ohm's law. And we're going to look at resistance and resistors. We're going to talk about the concept of electrical power, which is the same thing as regular power, but we just have a different formula compared to the formula we might use otherwise. We are going to learn about the difference between series and parallel circuits, and we're going to talk a little bit about batteries and power sources. And then we're just going to talk very briefly about microcircuits, integrated circuits, and digital technology. Now, even this is a summary of, we've got some logic gates, and that's important. We're going to cover logic gates in this. And we'll quickly maybe talk about integrated circuits. So even this is much less than what we cover in Year 12. In Year 12, we have an entire chapter that's dedicated to telecommunications. And telecommunications is pretty much entirely electricity or electronics. But that gives you a pretty good overview of what we're going to be doing in this video. And I won't go into quite as much detail as I have in other videos. There are other videos I've recorded where I talk about, for instance, in particular, impedance, reactance, and Lenz's law. I'm only going to cover those things incredibly quickly in this video. So I do have questions, and I do have, so for instance, some a quiz, like a Google form that you can fill in as a quiz to assess your knowledge of how much you've learned here. But we're going to go through these at really high level because they've been covered in other places. So now that we've looked at an overview of what we're going to do in this video, let's get started. The first thing you need to know is these concepts of electricity. Okay, well, what is electricity? Electricity is a flow of electrons. So it doesn't have to be electrons. It can actually be the flow of anything that can carry electrical charge, which we've learned earlier can include ions. Okay, so I've got this document here, and I mean, no one's really interested in reading this whole document, but I'll quickly summarize it for you. Okay, well, first of all, Electricity can be described as the movement of charged particles, including electrons or ions. Everything is made of atoms. Atoms are tiny. There are about 100 different kinds of atoms called elements. Atoms are made up of smaller things, protons, neutrons, and electrons. All of this should be familiar to anyone who's listening to this. Okay, normally atoms have the same number of protons and electrons. Neutrons are more complicated, and we're not going to worry about that at the moment. We have covered them previously. They're in the textbook, but we're not going to worry about that for the moment. Protons have a positive charge. Electrons have a negative charge. When an atom has the same number of protons and electrons, it has a neutral charge. So that makes sense. If we have too many protons, we're going to have a positive charge. If we have too many electrons, we're going to have a negative charge. But normally, an atom has the same number of positive and negative. So helium, for instance, has 2 electrons and 2 protons. So it's neutral, like Switzerland. Protons and neutrons both stay in the middle of the atom, called the nucleus. We know about that. Electrons fly around the outside or orbit. They orbit in shells. We're only interested in the outside shell, called the valence electron. Now, most elements don't have a full 8 valency electrons. Helium and hydrogen, they're a little bit different, but we're going to say that 8 valency electrons are going to be good enough for this course, right? Going to get you through HSC engineering. To be honest, it's probably going to get you through undergraduate, the first 3 years or 4 years of uni as well, but it depends on what course you do. Okay, metal elements, so for instance iron, aluminium, copper, they only have a few valence electrons, so it's easier for them to lose electrons in order to be stable. Lithium is a metal that only has 1 valence electron, so we could say it has a valency of 1. Magnesium has 2 valency electrons. What that means is it's only got 2 electrons in its outer layer. When I've talked about this previously, in the chapter 1 book, we talked about where it sits on the periodic table, tells us how many valency electrons it has. Non-metals, like oxygen, for them, it's easier for them to gain electron in order to have a complete shell and become stable. Oxygen has 6 valence electrons, so that means it really wants to gain 2. And this is written as O with a -2 as a superscript. When an atom loses or gains an electron, it's no longer neutral. What is that called? Do you guys remember? It is called an ion. I-O-N, not iron, iron. Yeah. So like there's a band, Iron Butterfly. Yeah. Yeah, that's the band, and they have a. Anyway, I'm not going to look that up, but if I was in class, I might look it up, but not for this video. I'll write it down as a thing to look for later. They're like, it's from the 60s, Iron Butterfly. Anyway, we're talking about ions, like TIE fighters. They're made of twin ion engines, if anyone's a Star Wars fan. A metal that loses its valence electron, well, if you lose an electron, you're now less negative. If you're less negative, you're positive. Whereas non-metals, they gain electrons, and that electrons that have a negative charge, so if you gain an electron, you're going to be negative. Does that make sense? Metal ions, they're positive. Non-metal ions, they're negative. They have a negative charge. There are 3 main ways that atoms become stable. Atoms can share their electrons in covalent bonds. We've talked about that. Metals can hold their electrons between non-metals in what's called an ionic crystal. And that's an example of that is table salt. Metallic bonds are crystals of metal ions, right? And so